Hey y'all, this is me again. Yeah, first time I was watching myself the whole time and my little face was off the screen, so you got to see nothing but my hand. So, I don't know what's more awkward, seeing my ugly mug or to see just my hand. Well, you're going to get both and you can give me feedback on which you like. Okay? So, first off, time is of the essence. I gotta move. So, one of the questions you might have is, how do I do the inequality thing? Okay, earlier we had one that was a circle, and you had something with this symbol, or if you have this symbol. We know that graphically we should always remember that this is going to be a solid line, okay, because it's including. So if I had a circle that says that, it's going to be a solid line, number one. But how do you know what side to shade? Do you shade out here, or do you shade in here? Which one? Okay. Well, one of the ways you can always do is do a test point. That's always a good idea when doing inequalities, is using a test point. So what that means is you test what side of the graph it makes the value true or false, depends on what you use. Okay. So let me bring up an example real quick. Okay, so I have this circle here, all right, and you can see here we've got this situation where the center is going to be at -3 and -3, 2. Okay, so -3, 2 is the center, the radius is 5. Okay, this is with the circle. Okay, circle format. Got the situation going on here. Center is going to be right here at -3, 2. Try to bow your circles out. I try to bow it a little bit when I draw it, and I know that kind of forcing it to bow out a little bit helps form a circle. Or you can use like some bottle cap or something helps, or one of those circles already done. Again, getting the same idea. I did something wrong there on purpose. Okay, this here, all right, this is going to be dashed. All right, so I spent all that time now doing that, and now I got to get my eraser out and spend all that time to erase, and get it dashed. And I don't have an eraser on the end here, so so I've got to get the this is going to be dashed. Okay, and then dashed. Now what side to shade on? Well, a nice test point is always 0, 0. 0, 0 is a great test point. All right, it's less than. This is saying all boundary less than this, so you kind of already know it's going to be inside. But you can always test a point, 0 in there, so that's going to be 3 squared, plus 0 minus 2, so that would be -2 squared, is less than 25, so that would be 9 plus 4. Is 9 plus 4 less than 25? That is true, so then you shade the region that makes it true. Okay? Booyah. Now on to ellipses. So, okay, go ahead and read the definition of an ellipse on your own. You've got the book, you've got the blue boxes, but circle is going to be the only different one. The rest of these conic sections or quadratic relations are going to involve this similar equation. All right, so let me get the equation here, and we're going to all try to get to this format. And let me write it down here. Sorry, I'm not looking at the camera. All right, and it's in your book. And I'm going to focus here on the terminology. And different math books will use slightly different symbols, but pretty much they're all the same. Okay. Now, the only difference here is if there were an inequality, same thing. If it were greater than or equal to, then you'd use solid line. Less than, then you'd use a dashed line. But so if it's an ellipse, if it's less than, then it'd be dashed, and then you would need to decide, you have which side do you shade on, outside the ellipse or inside the ellipse. And again, use a test point, or think about how this would be true. Test point always is pretty simple. 0, 0 is one of the best ones to choose to plug in there. All right, here we go. We want to get ours into this format. All right, it's going to evolve very similar to what we did with the circle, but there's going to be one last step. Okay, a little bit more trickier on the factoring, because we want to get it into this format. This is really nice. Okay, so first off, it's a very similar circle where you've got your center of your ellipse is right here. H and K is your center of your ellipse. But then an ellipse, it's not like a circle. Circle is a fixed point with equal distance from there. An ellipse is not. If you think about an ellipse, it's got this and this. This is called the Rx, and this is called the Ry. Okay? This is called the X radius, and this is called the Y radius. Okay? It's equal distance here with the Rx here, and this would be the Ry here. Okay? So in this situation, this ellipse is long in the X direction and short in the Y direction. So the long and short, we use terms called, so the whole thing across here, and it's in your book, is called the major axis, and the whole thing across here all the way down would be called the minor axis. All right. Now if it were flipped this way, okay, then the major axis would be the long in the Y, and the minor axis would be the short in the X. Okay. So that's the difference between major and minor axis. Well, we've got to get it to this format. All right. So let me pause a second and write down the equation. All right, I've got a manufactured easy one here. Okay. This one's nice because there's no x and y term. There's an x squared term and a y squared term. Lord willing, we'll have time to do a more challenging one. But how do we get there? Well, we need to get this into, oops, sorry, I copied the problem down wrong. My apologies. 225. All right, we got to get this to be a 1. Okay, manufactured problem right here. It's like, hey, look at that. This is 225. Well, really what you're going to do is you're going to divide every single term by 225. Okay. Well, again, manufactured problem, so this is nice because this will work out. 225 is the product of 9 and 25. So super nice here because then this becomes x squared over 25. And then this becomes y squared over 9, and then that equals 1. All right. So we're so close to the format. The last step is we factor out the square term to get it into the format up above. Now this gets really tricky if you have to deal with radicals, but it still can be done in calculus. You're going to probably most likely doing radicals, and we'll have decimal approximation when we're graphing. But anyways, perfect square here, perfect square here. Now to graph, the h and k term, if you're going back up here, they're 0. Okay, so that's why this one's easier because they're both 0. All right, didn't have to do much work. The original was up here, just had to divide by 225 and booyah. Now, which is it long in? Well, which is the bigger number? 5 is bigger than 3, so this is going to be long in the x, kind of like this one up here. And so it's going to be 5 units long in the x, and then 3 units long in the y. And so if I were to graph this again, it would be center would be here. We'd go up 3 units, down 3 units, over 5 units, to the left 5 units, etc. And then you don't want to draw a football, so one way you curve it out, it helps to kind of curve it a little bit and bow it a little bit more. It's really easy to draw a football if you don't focus on that. So ish. All right. I'm again the time factor here, and I'm not using grid paper, but I think it helps with the clean white paper, but construction paper, computer paper. All right. So let me pause again. Let me write down the other formula and see about a little bit more challenging one. Okay. Here we go. This one's going to involve a terms and adding problems to the other side, very similar to what we did with the circles. So hold on. Okay, so we have, one thing I forgot to mention is the formula given in the very beginning quadratic relation. This is the formula for a quadratic relation. If it matches this is a quadratic relation. Okay. Well, obviously any one of these could be a 0. All right. Well, then it kind of changes. We could get a linear equation, and it's not really a, no. Well, it could be really, yeah. Anyways, I'm gonna not digress here. So you'll note again, there's no bx term. That makes the algebra a lot easier. So again, we'll come back to that, but the bx is not there. So we have these terms here. Manufactured problem. It's going to get easier. But right now, let's align our terms here. 49 x squared plus. Actually, it's going to be minus. Okay, let me get my eraser. minus 196x. All right, and I'm going to go ahead and do this plus this, and then I'm going to do a plus, a big plus here. All right, and then 9y squared plus 72y plus this. And I like to set it all up like that. Okay, so it's all lined out, and similar to, so I added 101 to the other side. I made a blank here because I'm going to complete the square on both of these terms. But before I complete the square, again, I got to factor out the quote-unquote a term here. All right, or the term in front, so not in front of the square term. So I'm going to factor out the 49. Got x squared. That becomes minus 4x. 196 divided by 49 is 4, plus something. I like to do it all at one time because over here we divided. I factored the 9 out. Factor the 9 out. Factor 9 out of 72 is 8, and then this here, and then it's an equation. So what we do to one side, we must do to the other. So 49 multiplied by plus 9 multiplied by, okay, so over there, that's hard to see, but that's a 49 multiplied by and a 9 multiplied by. Okay, so how do we get this? Well, this is b divided by 2 squared. B divided by 2 squared. So now it's, I'm going to go ahead and write those in for time's sake here. Oh, there went my soccer ball. 4, and then 8 divided by 2 is 4. 4 squared is 16. So write those down. Okay. All right. I'm going to go ahead and just, all this is 101 plus this is 441. Okay. And then this is going to, that's the whole point of this. We split it in the middle term so we can factor this. It becomes a perfect square. So now this is 49 multiplied by x minus 2 quantity squared. And this is now plus 9 multiplied by y plus 4 quantity squared. That was the whole point of this, is to get perfect squares. Now if you remember with the ellipse formula, it's different than the circle. We don't have radius squared. We want to set this equal to 1. Alright, by setting this equal to 1. Well, I can't just make it 1. I can just, okay, it doesn't mystically become 1. We have rules that we have to follow. We divide every single term by 441. So divided by 441, divided by 441, and divided by 441. This is where the nice manufactured problems come in. Yay! 441 is, it's the product of 9 and 40. Okay, so 49, so this becomes x minus 2, and you had quantity squared here, divided by 9, plus y plus 4, divided by 49, equals 1 squared. So close to the end. Remember the formula had Rx and Ry. This is not Rx and Ry yet. Remember, they're squares. The formula had, now these are nice, happy, perfect squares. So again, manufactured problem. One final step to get this in, and this involves your exponentiation rules, okay, which I'm not going to have time to go into, possibly. Actually, yeah, you can if I had like x squared, like what we did, x squared divided by like 3 squared. Okay, we could call that x divided by 3 all squared. Okay, and that's essentially what we have. 49 is 7 squared. And so by doing this now, okay, we get it all in one format. I'm running out of time here, so I'm not going to be able to graph this, but you'll be able to. So the center of the ellipse, h and k, think about what's going to make these zeros. So 2 minus 2 is 0, negative 4 plus 4 is 0. So the center of this ellipse is at positive 2, negative 4. Remember, y and or x and y format always, 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 x and y. And then what's rx? Rx is going to be 3, and ry is going to be 7. So from 2, negative 4, you want to go to the right 3 and to the left 3, and you want to go up 7 and down 7. All right? gonna probably have to be signed off.